Imagine the terror our ancestors must have felt as they emerged from the caves. Look up at the night sky, one of the few dependable things in their lives, and there, a long arc of light suspended. Awesome. A sign, and perhaps a message from the gods.
I may therefore with some confidence predict its return in the year 1758. If this prediction is fulfilled, there is no reason to doubt that other comets will return.
Like all good scientists, Halley was a storyteller. His story rang true, and it has become part of our knowledge. Knowledge that helps us feel more at home in our universe. We now know that Halley's Comet has been visiting our neighborhood for at least 22 centuries, ever since Chinese astronomers first recorded its passing in the year 240 BC. Every 76 years, on average, this same comet threads its way through the solar system like a needle, stitching our past to a possible future. And it may carry with it the stuff of creation. Stardust thrown off when the planets first formed 4.6 billion years ago. The same stardust that we are made of. And in that very basic sense, Halley's Comet is family. Because Edmund Halley's story has stood the test of time, we need no longer fear the strange apparitions the Greeks called hairy stars. Because of Halley, we can celebrate the comet's return, and that's what this story is about. Let's begin by finding out what a comet is. Astronomer Ed Krupp, director of the Griffith Observatory in Los Angeles, can tell us.
Look, if you had one of these in your backyard, seeing Halley's Comet would be easy. But even with a telescope like this, you'd have a tough time knowing exactly what a comet is. The largest telescopes on the Earth, like the telescopes at Lick Observatory or the 200-inch telescope on Palomar Mountain, even those huge telescopes have only been able to give us an inkling of what a comet might really be at the business end. But by studying the information that we obtain at the cold ends of these telescopes, we come to the conclusion that the best guess that we have for a comet is that it's something like this. A dirty, giant snowball from interplanetary space. In the case of Halley's Comet, it may be anywhere from 3 to 10 miles or so in diameter. Well, these snowballs are really quite numerous. We imagine them to be all over the place, about 3 trillion or so miles in every direction from the sun, out in a cosmic refrigerator that astronomers have come to call the Oort cloud. And we imagine that from time to time, due to the tug of gravity, one of these comet nuclei is nudged into a path that carries it in toward the solar system and the sun itself, much closer than it normally be. When it gets in among the planets, it's possible for gravity to nudge it a bit more. We think that may have happened with Halley's Comet, too, so that the large planets have caused it to settle down into a long, kind of hot dog or cigar-shaped orbit that carries it out past the planet Neptune and, of course, very close in toward the sun. And when it gets close enough to the sun, it's heated up, of course. And the sun's heat causes part of this material to vaporize off the comet and develop into a huge cloud, or head, or coma of the comet. That head of the comet can be many times the size of the Earth. The head of a comet certainly is spectacular, but it's really the comet's tail that captures most people's imaginations. The comet tail, in fact, is produced by the pressure of sunlight pushing on the particles of dust that have evaporated off of the comet. And that pressure stretches that comet's tail out to, well, maybe 100 million miles long. That's, in fact, about the distance between the Earth and the Sun. And in 1910, that's just how long the tail of Halley's Comet developed to be. Well, that's one tail, but comets very often have two tails. The second tail isn't made of dust. It's made of electrically charged gas, or plasma, as comet scientists call it. Now, that tail differs from the other one in part in color. It's also produced differently. The comet tail that's made of the electrically charged gas is produced by the pressure of the solar wind blowing on the comet and stretching that tail out also in the direction away from the sun. Well, the dust tail appears to be yellow. The plasma tail appears to be kind of bluish white. In the good old days, comets were renegades. They'd come out of nowhere and they'd disappear just as fast. And they didn't seem to obey the rules. But it was finally discovered that comets obey at least one rule, and that rule is that the tail always points away from the sun. That's, of course, because of the solar wind and the pressure of sunlight blowing away on that tail and stretching it out. That discovery was made by Peter Apian in the 16th century, about 1531. And it means that as the comet rounds the sun, it's possible for the tail of the comet to be in front of the comet itself, to lead the comet as it continues on its outward bound path. Well, it's the tail, of course, that gets all the attention, sunlight reflecting on the dust. And recently, we've managed to learn a little bit more about the tails of comets because we've sent a spacecraft right through the tail of a comet. In September 1985, the International Cometary Explorer, ICE for short, passed through the tail of Comet Giacobini-Zinner. Not exactly a household word, but still a comet that taught us something about what comets really are. And slowed down in a way that our own ears can hear, this is the sound of what it's like to fly through a comet's tail. Now, there's really not very much to the tail of a comet. It's all pretty insubstantial stuff. You could take millions of miles, millions of square miles of comet tail and squeeze them all down into a suitcase and still have room left over for a toothbrush. You could walk off with it.
The story of the comet getting all dressed up for the sun is really a rags to riches fairy tale. Cinderella goes to the heavenly ball. And if it's trailing a gown 100 million miles long, how could we possibly miss it? It's easy if you're 40 million miles away, and that's the closest we'll come to Halley's on this trip. Viewing conditions are the worst in 2,000 years. So don't expect the comet to look like a bright streak of silver spray paint. It won't. It'll be hard to find. But with our help, you can do it. At NASA's Jet Propulsion Laboratory, Don Yeomans, a member of the International Halley Watch, has been keeping close tabs on the comet for some years. He knows precisely where it is. In 1982, the giant 200-inch telescope on Palomar Mountain took the first picture of the comet's return. It was almost exactly where Yeomans had predicted. Edmund Halley would have been proud.
On January 24th, 1986, the Voyager 2 spacecraft, much like the spacecraft behind me, makes its closest approach to the distant planet Uranus. For observers on the Earth, the Voyager 2 spacecraft will provide us with our first close-up look at this very distant gaseous object. But you know, for Comet Halley, during its 200,000-year history, the planet Uranus is a very familiar sight in its 76-year milk run through the inner solar system. But in a sense, the return of Comet Halley to the Earth's neighborhood is a first as well. It's the first time the comet has returned in the space age. It's the first time it's returned in the age of computers. But 300 years ago, when Halley was alive, they didn't have the benefit of high-speed computers. In fact, when Halley first observed his comet on September 5th, 1682, at 7:30 in the evening, all he had was a simple telescope, and he jotted down his observations with a quill pen on a piece of parchment. And he began to wonder, just what kind of paths do these comets take on the sky? Do they move around the sun like the planets do, or are they moving in a straight line? like most people thought at the time. Well, he didn't really have the mathematics or the physics to understand that question, but he knew the man who did. So he went to his friend Isaac Newton and asked him just what were the laws that governed the motion of these bodies. Well, Newton was reluctant to publish his results, but he knew, and Halley twisted his arm a little bit and got him to publish his results. And not only that, but he actually helped pay for the publication costs. And so we owe a great deal to Edmund Halley for having leaned on Isaac Newton a little bit and getting him to publish his results in the famous Principia of 1687, perhaps the most important book in physical science. Now, using the techniques that Newton set down in his Principia, Halley actually gathered together observations from 24 well-observed comets and computed their orbits. He noted that 3 of them, those observed in 1531, 1607, and the comet that both he and Newton had observed in 1682, had very similar paths on the sky. And he boldly suggested in 1705 that these apparitions of this single comet would have another apparition in 1758. And when the comet was in fact recovered by a German amateur astronomer on Christmas evening, 1758, not only was Halley's prediction verified, but the theory upon which Halley's prediction was based, Newton's theory of gravitation, was also verified in a very dramatic way. Now, what you're interested in is where is the comet when it's most bright? From November 1985 through April of 1986. And it's my job to make those kind of predictions. What we do is we take old observations of the comet and we fit our theories through them, and then we make predictions based on these theories. And in November of 1985, the comet will be in the constellation Taurus. It will then move out of Taurus into the constellation of Pisces, and then into Aquarius, Capricornus, Sagittarius, and Scorpius.
Well, it sounds simple enough. Head north to Taurus, hang a right, and follow the Halley Highway. That's like telling someone who's never been to the United States how to see the sights in New York or San Francisco. First, you have to point them in the right direction, and for that you would need a map, and they would have to understand how to read it. It's the same thing with the night sky. With just a little patience, those twinkling beacons can become as familiar as the Golden Gate Bridge or the Statue of Liberty. We're going to take you on a tour of the constellations, and Ed Crump is your guide.
On a clear, dark, moonless night, you could probably see, a few thousand stars with the unaided eye. But that's, of course, if you're far away from city lights. Most of us live in large cities, and all of those lights just drown the nighttime sky, and we lose most of those stars in the reflected glare. Still, it's pretty crowded up there, and if you're not used to strolling among the stars overhead, it's pretty easy to get lost. Now, from November through April, Halley's Comet moves through 6 constellations of the zodiac. And if you want to see Halley's Comet, it sure is going to help to be able to know where it is and where those constellations are. Now, that's pretty easy, provided you know which way to look and how high in the sky to look, too. And you can figure that out if you're oriented. Now, this building is oriented. It's laid out on a north-south, east-west axis. And so I can use it to figure out where to look. Most of it will be in the southern part of the sky, the southern half. So to do that, come on over here. If you don't have a building, you're probably going to need a compass. That'll tell you which way north is and which way south. Now, that way is north, that way is south. Now, in the middle of November, Halley's Comet is in the constellation of Taurus the Bull. And if you know those stars, you can tell that the comet is between the bright star Aldebaran, that's the bull's eye, and a cluster of stars which is called the Pleiades. A lot of people call it the Seven Sisters, although you can only see 6 of them with any kind of luck at all. But that's pretty easy to pick out in the sky, too. But if you're not used to looking for it and you don't know where it is, then what you do is you start from the direction north to face the right direction. So for mid-November, about 9 o'clock at night, you turn to the east. From north, that's about a quarter of the way around the sky, like this. And then you have to look up about halfway from the flat horizon to the top of the sky, which is straight overhead, of course. That's 90 degrees, so halfway is about a 45-degree angle. And that's just about in the direction of Taurus the Bull. Now, in November, the comet is still very faint, so you can only see it with binoculars, but at least this will get you in the right direction. About a month later, on the 12th of December, say, that's a good night for no moon interfering, you can find Halley's Comet if you can find the constellation of Pisces the Fishes, because that's where it is. So at about 9 o'clock at night, you've got to face that direction, and that direction is, well, all the way around to the west, in fact. It's just a shade to the south of west, just a little bit, about 5 degrees or maybe about the width of your hand from due west. And then to look up about 35 degrees. Well, most of us don't carry a protractor around to measure angles in the sky. 35 degrees is about a third of the way from the horizon straight on to overhead. So 35 degrees, about a third of the way up, and right around almost to due west, just a little bit short to the south. That's where Pisces the Fishes will be, and that's where Halley's Comet will be too. In January, on the 10th, say, the comet should be pretty good for viewing in the evening sky before it disappears and goes behind the sun. And to see it in the evening sky at that time of its path, you've got to again face to the west, a little farther to the south, though, this time. Now you're facing about 20 degrees or so to the south of west. That's about west-southwest. And the comet is going to be lower, too. This is, say, about an hour and a half or so after sunset. The comet then will be about 22 degrees above the flat horizon. Well, that's just about a quarter of the way up from the flat horizon. It's in the constellation of Aquarius. That's Aquarius, the water carrier, out west-southwest and about a quarter of the way up the sky. Now, if you want to see Halley's Comet in February, you're out of luck. It's in the constellation of Capricornus, the sea goat, or the fish goat. Those stars aren't very bright, but that's also the same direction in which we find the sun at that time of year. And so the comet is actually going behind the sun, and it's lost in the glare of the sun, and we don't see it. It's going to come around the other side, of course, and as it does, it's going to be steaming. The sun has heated it up, and of course now the comet may in fact become brighter than it was before and may develop the tail much longer than we've already seen. So we're going to be wanting to watch for it, and March again is the time to have your eye out. Say, maybe beginning around the middle of March, the 15th of March or so. Then you would look not in the evening sky, where we saw the comet earlier, but in the morning sky, because again, now the comet is coming up before the sun does. So what you have to do is look out instead to the eastern half of the sky, actually to the southeast, out in that direction, southeast, and then say it's about 4 o'clock in the morning, a couple of hours before sunrise, you're looking up at an angle of about 12 degrees. Now 12 degrees above a flat low horizon. That's not very high at all. In fact, just to get an idea, it's roughly the width of 4 fingers twice. One set of 4 fingers and another set of 4 fingers on top of them like that. That's just about the right angle above a flat horizon to be looking in the direction of the constellation Sagittarius. Sagittarius is the Archer Centaur, and Halley's Comet will be in those stars in the early morning around the middle of March. The last half of March, you want to really start watching the comet pretty carefully. It's moving through those constellations of the zodiac, and it's developing as well. By around the 5th of April, say, the comet is in the constellation of Scorpius, the Scorpion, and it's just, in fact, below the curve of the tail of the Scorpion that's such a conspicuous part of it. It's still in the morning sky, of course, and so you have to look out more or less to the east and southern part of the sky, and it's low in the sky as well. Well, if we say 4:30 or so in the morning, we look due south, and look up again at about 12 degrees, about 2 hand widths again above the flat horizon. That's where constellation Scorpius is located, and Halley's Comet is in those stars just below the curving tail of the Scorpion. During Comet Halley's 1985-1986 World Tour, there are 2 prime times to view it. One is, well, from the end of December into the first couple of weeks or so of January 1986, and the other is in the spring of '86, end of March, first part of April. Now, for people in the northern hemisphere, probably the best time is in that end of December, early January period, when the comet is in the evening sky and will be fairly high in the sky as well. After Halley's Comet rounds the sun, it will be brighter and the tail will be longer. But again, for people in the northern hemisphere, it'll be harder to see it. The comet is going to be lower in the sky, closer to the horizon, and certainly going to be a lot tougher to make out against any background light. But the southern hemisphere is going to get the real show in March and April. And if you want to see Halley's Comet at its best, you should go south. Go south to, well, Australia, South America, wherever. because then, in March and April, Halley's Comet isn't going to be low on the horizon. It's going to be way up in the sky. You're going to be able to watch it for hours, near, in fact, overhead. And so the best views of Halley's Comet are going to be for those folks in the southern hemisphere when the comet is doing its best.
You don't have to be a professional astronomer to have fun getting lost in the stars. Ben Mayer is a graphic designer who began looking at the heavens a few years ago, and as a result, he came up with a novel way to find and photograph the comet.
The lovely part about Halley's Comet is that we have only one chance in our lifetimes to really see it, and we might as well make the best of it. And it behooves us to go out and make everything happen that we possibly can to see the comet. When I first became interested in astronomy, I thought surely it'll be easy to find objects in the sky because I saw atlases which showed vertical lines and horizontal lines describing exactly where everything in the sky was located or supposed to be located. But when I went out and looked at the sky, there were no lines there at all. It was all one large black area with stars. And so I thought there must be a way that these lines in the sky can be duplicated. And so I figured out a method which I found very useful. It involves nothing more than a plain wire coat hanger. The plain wire coat hanger that I'm using here is for the purpose of defining an area in the sky which we can find again and again on different occasions. And this is what I call a star frame. A star frame then is no more than a region which very clearly defines for us where we are looking. All we need to know is at what angle to hold it and in what position to hold it in the sky. Now, if you can, you should be able to read up beforehand where the comet will be when. You can get some saran wrap, which you can stretch over to your star frame, and some white typewriter correcting fluid, and some luminous ink. With the luminous ink, you can mark, in fact, you can trace from the book the principal stars in the region. And with the white out, you can trace the path of the comet through the constellation, and they're all shown, and show where it will be in relation to the brightest stars in the field. Now, this is the constellation of Aquarius, and it shows where the constellation will house or will play host to the comet in December, January 1985-86. Now, we have wonderful tools at our disposal today in our kit, and the camera is perhaps the most important one of them, because the camera is an accumulator of starlight. Through the lens of the camera, starlight enters the film cassette for as long as you leave the lens open. You want to leave it as wide open as you can, and you want to put as fast a film into the camera as you can. Then you clamp or secure the camera either to a shelf or to a tripod, and you aim it at the region where you know even now that the comet will be at any given point, and you take a picture. A picture that you will leave open for about 10, 15, or even 20 seconds. Then you close it. And then you take a second picture a night or two later, and in this manner, you can actually find where the comet was and where it is now. It'll draw immediate attention to itself by moving back and forth. It is so simple, you won't believe it. It'll make anyone into a comet discoverer and can take you far beyond your camera into the reaches and the area of astronomical discovery. Here are two pictures I took just the other night of Halley's Comet. They were among the very first photographs of Comet Halley taken in the 1985-86 apparition, and I'm sharing them with you very proudly. Here's what I did. I took the first photograph, this photograph, on one night in September, and then I waited for 24 hours before taking the second picture. So these photographs were taken 24 hours apart. During that time, of course, Halley's Comet moved. I know exactly where it is in this picture, and I'll show it to you now before I'll make it reveal itself. This is Halley's Comet. You must take my word for it, but I'll prove it to you right now. By showing a second picture in combination with the first one you just saw, I can make the comet give its position away. It blinks back and forth, which is why this device is called a blink comparator. It shows quite readily that this is the only object that moved. Everything else stood still. All the other objects in the field were stars. Only this one object was a comet. And that's how you can discover not only Halley's Comet, but any other comet if you set out on a comet quest of your own.
No matter how tough it may seem at first, don't get discouraged if you don't see Halley's right away. We want you to have fun chasing the comet, and if you don't, something's wrong. And if you ever get frustrated trying to find Halley, Don Yeomans can tell you how tough it is to get 5 separate spacecraft to chase the comet.
The nice thing about this Voyager spacecraft is it has a very sophisticated television camera system on board. It can actually use these sophisticated eyes, if you will, to zero in on the target that it's trying to observe, much like a bird in flight uses its eyes to zero in on its prey. Now, the 5 spacecraft that are encountering Comet Halley in March of 1986 also have very sophisticated camera equipment on board, but they can't use that equipment to zero in on their target. And so it's left to myself and my colleagues here at JPL to provide the very best cometary positions from ground-based observations alone. But if we do our job well, then we can guide the Soviet, the Japanese, and the European spacecraft as close to the comet as they would like to go. And there's a good chance that during this 1 week in March of 1986, we'll learn more about comets than we have in the previous 2,000 years. What excites me about these missions to Comet Halley is that for the first time, man is actually going out and looking at this comet up close. It's not like the past 2 millennia where we've had to watch these things from the ground. We're going to find out for the first time, what are they made out of? What do they look like? What size are they? How much mass are they losing each time they come near the sun? How long will they last? We know that Comet Halley is coming back in 2061, in the summer of that year, but it won't be any more impressive then than it will be this time. But in 2134, May 7th, the comet will come closer to the Earth than it has since the 9th century. It'll be brighter than the brightest stars. So tell your grandchildren to tell their grandchildren to mark that day on their calendar. That should be a real show.
Comet Halley may die a small death every time it passes this way, but through the centuries, there have been many who believe the comet was sure to take us all with it. It's still happening, even today. Listen to this. This is part of a notice found on a car windshield a few days ago. Behold, Halley's Comet is coming. The end of mankind is near. Most terrifying and destructive events, earthquakes, floods, war, death of kings, fall of nations shall happen soon. Well, maybe, but it won't be the comet's fault. The last outbreak of comet fever was in 1910. Some said Halley's would strike the Earth and tear it apart. Others feared that the comet's tail would bathe us all in deadly gas, and hucksters sold comet pills to ward off the dreadful effects. Why were people so terrified of a comet? Well, imagine how England's King Harold must have felt as he prepared for William the Conqueror's invasion in 1066, and Comet Halley appeared in the western sky. There was always something to blame on Halley's. Of course, there's a chance that someday the Earth will be hit by a comet. It may have happened as recently as June 30th, 1908, in Tunguska, Siberia, around 7 in the morning. A mysterious fireball exploded at a height of 5 miles, leveling a vast forest, incinerating a herd of reindeer, and scorching trees for miles around. A farmer living nearly 40 miles away was blown off his porch and had his shirt nearly burned off his body. It wasn't until 19 years later that a scientific expedition reached the site. There was no crater, but in the trees and soil were tiny fragments that may have come from an asteroid or comet. Other scientists have suggested that cosmic collisions were responsible for a series of mass extinctions, like the death of the dinosaurs about 65 million years ago. And there's the other side of the coin, comets as bringers of life. Could they perhaps have seeded the primordial soup of Earth with microscopic life forms that began the process of evolution? It's a little embarrassing to think that we may owe our origins to a kind of cosmic contamination. Anyway, this time, there's no reason to worry about Halley's Comet. The closest it will get to Earth is about 39 million miles. Our problem isn't avoiding it, it's seeing it. And the last thing you should do is take cover and hide. Instead, follow Ed Krupp's advice.
That view is pretty spectacular, and lots of people come up here to have a look at those lights. But those lights are really absolutely disaster if you're hunting for comets. And that's the first rule for Halley comet hunting. You've got to go someplace dark, far away from lights, far away from city lights. And you've got to be far away from moonlight, for that matter, too. You've got to go when the moon isn't shining. And when you're out there under that dark sky, don't forget to let your eyes get adapted to the darkness. It takes a little bit of time, and you don't want to ruin it. So take a red flashlight with you, so if you need to look at something, you can look at it in that dimmer light and not lose it. Also, make sure you find some high ground, so you don't have any obstructions. And don't forget the compass, too. You need that compass in order to orient yourself. So you've got your high ground and your compass, and you're looking for the comet, and there's one more thing besides warm clothing you're going to need in those early morning hours or early evening, and that will help your eye with these, the binoculars. 7 by 35s, 7 by 50s, they're the best thing that you can take along with you to make sure that you get a look at Halley's Comet. Now, when you're out there looking for the comet, if you're still having trouble finding it, you might check in with your local planetarium. Tell them what you've been doing, ask them for some hints. They'll probably be glad to help you. Good hunting.
Finally, I wanted to tell you some of the thoughts I've had about this story. Maybe the fact that seeing the comet really is a once-in-a-lifetime opportunity has made us conscious of its significance, how it links us to the universe we inhabit, and how it links generations past to those yet to come. There's a monument outside the Griffith Observatory. On it are the likenesses of some of the giants of astronomy, each in his own way a storyteller. Let me tell you about 3 of them. 500 years ago, a child built his own sundial at school. His name was Nicholas Copernicus. When he became a man, he told us a story of how the sun, not the earth, is the center of our planetary system. Another youngster was taken by his mother when he was 6 years old to see the great comet of 1577. When he grew up, Johannes Kepler told the story of how the planets move in elliptical orbits. In England, there was a young man who tied lanterns to the tails of kites to make people think they were seeing comets. Years later, Sir Isaac Newton, Halley's old friend, told us the story of gravitation and the laws of celestial mechanics. Let me bring the story up to date. In the 20th century, there was a child who left the big city for his first trip to the country. His reaction to the clear night sky? Awe. A feeling of immense loneliness, and at the same time, connection. He's telling you the story of Halley's Comet. His name, William Shatner. I know my experience isn't unusual. Ed Krupp, Don Yeomans, Ben Mayer, and many of you have shared something similar. All of us are simply doing our best to make sense of this strange, majestic, universe. There's no mystery to science. It's done by ordinary human beings with driving curiosity and a thirst for explanations. People like Edmund Halley. By all accounts, he was a man of integrity with a great sense of humor. He led a good life, enjoyed a happy marriage that lasted 55 years, and his mind was sharp to the end. On January 14th, 1742, at the age of 85, he called for a glass of wine, drank it, and quietly died. His skill lay in knowing the right questions to ask and where to look for the answers. Where to look and how to look. Now it's our turn. Hello, Halley.
Finally, these last minutes of this tape are designed for you to create a visual time capsule to leave for future generations of your family, so that they will know who you were and what happened when Comet Halley made its first pass by Earth in the age of television. We hope you involve your entire family. We suggest you make use of newspapers and magazines, photographs of other family members, and any bits of trivia and other material that you can show to the generations who will come after you. Rehearse on a blank tape before you record over this section. Then record your time capsule. Keep it in a safe place, and remember that too many playings and the passage of time will cause this tape to lose quality. Therefore, over the years, keep up with improvements in video recording, and whenever possible, transfer this material to ensure its survival for those who will wonder what it was like back in 1985-86. A video time capsule will be your way of guaranteeing happy Halley days for your grandchildren and their children in 2061 and 2134, when they look up and join the age-old hello to Comet Halley.